Welcome to Brain Vision.
When given a graph of velocity versus time, the average acceleration is simply the slope of a straight line between the 2 points in question. And so when we find the average accelerations in part A, we start with region 1, which is from 0 seconds to 10 seconds. So we see that we end at 60 meters per second, and we start at 0 meters per second. We end after 10 seconds, and we start after 0 seconds. This gives us an average acceleration of 6 meters per second squared. In region 2, at 40 seconds, we are at 0 meters per second, and at 30 seconds, we're at 60 meters per second. Of course, as I mentioned, we start at 30 and end at 40 seconds, and this gives us an acceleration of negative 6.0 meters per second squared. In region 3, from 10 seconds to 30 seconds, we can do the same method, or we can just look at it and see that this is a flat line with 0 slope, and so our average acceleration has to equal 0 meters per second squared. In part B, we want the instantaneous acceleration, and this is the slope at an exact point on this graph. However, on a straight line segment, the slope of that line is the same as the slope as any point on that line. And so, since the first point falls at 20 seconds on a 0 slope line from 10 to 30 seconds, we can see that the instantaneous acceleration is just 0 meters per second squared. Let me make that more clear. At 35 seconds, we see that this point lies on that straight line from the 30-second mark to the 40-second mark. And so it will have the same acceleration as part 2 up here in part A. So the instantaneous acceleration there is 6.0 meters per second squared. Negative.